Now we've talked about one measure of relative standing, and that was the z-score. Another measure of relative standing is quartiles, and then another one that we'll discuss are percentiles. Quartiles divide sorted data into 4 equal parts. Quartiles are useful for comparing data values within a particular data set. The data set must be sorted before finding quartiles. Now, the thing is, we're going to use our calculator to find quartiles, and I'll actually discuss finding the quartiles with you when we talk in the next topic about the 5-number summary. For now, I just want you to know that the first quartile, Q1, separates the bottom 25% from the top 75% of the sorted values. The second quartile, Q2, separates the bottom 50% of the sorted values from the top 50%. And the second quartile is also the same as the median. The third quartile, Q3, separates the bottom 75% of sorted values from the top 25% of the sorted values. So, we have a picture here, and it shows a very generalized set of data that's sorted with a minimum value and a maximum value. It's showing how Q1, Q2, and Q3 have broken it up into 4 separate pieces. Each piece is 25% of the data. Q1 gives you the bottom 25%, Q2 will give you the bottom 50%, Q3 the bottom 75%, and then you have the maximum value. And keep in mind the median and Q2 are the same value. Now percentiles are similar to quartiles. Just as quartiles divide the sorted data into 4 parts, percentiles divide the data set into 100 equal parts. And those percentiles are denoted p sub 1, p sub 2, p sub 3, etc., all the way up to p sub 99. To find the percentile of a given data value, first sort the data set, then use the following formula. So, finding the percentile of a given data value. You're going to take the number of values that's less than the data value you were given, where x is the data value you're given. Divide by the total number of values, and then multiply by 100. And you'll always round the percentile to the nearest whole number. So, going back to our set of ages for the 76 best actresses, we have a table here now where they have been sorted. We're going to be given a data value and asked to find the percentile. So find the percentile corresponding to the age of 30 years. So there is our X. And we're told there are 76 values. Now the formula was to take the number of data values less than X. So find your data value. There's 30. And there's actually 2 30s, but that's okay. Just pick the smallest one. And then we want to count the number of data values that is less than that. So counting those, we see that there are 26 of them. So we write the percentile of X, or of 30, is equal to 26. Divide by the total number of data values and multiply by 100. This is just like finding a percentage. You would take a part and divide it by a whole and then multiply by 100. So when we do that, we get 34. Remember, we round to a whole number. So that is P. 34. That would be our answer. Our percentile is P sub 34. Now, what if you're given the percentile and asked to find the corresponding data value? If that's the case, you first have to locate the data value. So L here is for locator. That gives you the position of the data value. It does not give you the actual data value. So, first step is to follow this flow chart, sort the data, lowest to highest, And then compute your locator value. That's very important. And it's going to be K, where K is the percentile being used, divided by 100, and multiply by N, where N is the number of values. And that's just like finding the percentage of a value. For example, if you want to know what is 30% of 110, you would take 0.3 and multiply by 110. In this case, say we're using a percentile of 26. We would say 0.26 times our 76 actresses. So, and that's going to give you your locator. But you have to figure out, do you need to round? Is L a whole number is the next question you need to ask yourself. If it is not, change your locator by rounding it up to the next larger whole number and then count over to that number of values in the table. If, and I'm on this last box now, if L is a whole number, then the value of the kth percentile is midway between the nth value and the next value. So you would find your locator, find that value on the table, take that value and the one above it and find their average. And that would be the data value that corresponds to a given percentile. So, find the value of the 20th percentile. So we first find our locator. And again, that's your percentile over 100 multiplied by the number of data values. Well, 20 over 100, that's just 0.2. So if you don't want to write it over 100 and just know that you're changing that to a decimal, so 0.2 times 76 is 15.2. Since we ended up with a number that was not a whole number, we round it up to the next whole number, which is 16. Now, we'll count over 16 places on our table. Each row had 10, so on the second row, 11, 12, 13, 14, 15, 16. So, our 16th data value is 27. So P sub 20 is equal to 27. Alright, now just a what if. What if our L had been 15, a whole number? In that case, you would go to the 15th data value and then look at the next data value as well. Add those together, 27 plus 27, and divide by 2. The average of 27 is 27. And again, that is a what if my locator is a whole number? Then you pick that value and the next one and average them together. If it's not a whole number, round up to the next whole number and then go find that value in your list of data.